Hello everyone, my name is Ankit Nanwal and today we will be starting with the second lecture on influence line diagram. So today we will be learning about how to make influence line diagram in cantilever beam. So suppose this is a cantilever beam that I have taken here. Okay, this is A point, this is B point and total length is L. Now when we want to draw this influence line diagram for the cantilever beam, first of all you need to make influence line diagram for the reaction and influence line diagram for the shear force and influence line diagram for the bending moment. So first case is when I want to draw the influence line diagram for the reactions. So here how many reaction will be there? One is Ra, one is Ha, and one will be moment, that is Ma. So these are the reaction. First of all we need to calculate the value when there is a unit load acting here. Okay, when unit load is acting here somewhere here, suppose this is distance x. Now summation fx equal to 0, the first equation there, from here we will get h equal to 0, and second will be summation fy equal to 0, that will give ra equal to 1. Okay, now we have got the value of ha, ra, and we will get the value of ma. Ma will be equal to, as this is anti-clockwise, the other one way is clockwise, that is ma I have taken positive, so minus, this will give you 1 into L minus x equal to 0, and from here we will get ma equal to 1 L minus x. Okay, so I have got all the reactions here. Now when I have got the reaction, first of all I need to make reaction ILD. So reaction here is Ra. So for that, what is the procedure? Procedure for making ILD, I have told you that you have to consider a section here. Suppose I have considered a section at here now. Okay, so this distance is small a, this is x section. Now this distance is x. For that, now for reactions, okay, how will you make the influence line diagram? As you have the value of Ra equal to 1, here there is no term of x and with reference to a and l, there is no term here, so we have the value of Ra as 1. So as Ra is 1, when x equal to 0, then also Ra will be 1, and when x equal to L, then also Ra value will be 1. So simply you need to make an influence line diagram, as this is the span. When x is equal to 0, from here x equal to 0, the, this is 1, and when n x equal to L, this is 1. So this is the influence line diagram for the reactions in case of cantilever. Now comes the second case, that you need to make the influence line diagram for shear force. Okay, shear force. So how will you make the influence line diagram for this shear force? So first I have taken a section here. So write down the equation for shear force at xx. So shear force equation, let this point be C here. Okay, so as this point is C, so shear force at C will be how much? Put your hand here at this point. Put your hand here at this point and see the reactions. Shear force at C will be 1. Okay, and 1 you can see, as we take from right hand side, when we are taking from right hand side, when we are talking about right hand side span, and the forces that are coming downward, that are taken as positive, Okay, now when the unit load from here, you can see at this point the unit load is when I have put my hand at section XX and I am seeing the section from right hand side. So one force, that is one unit load, is coming downwards, and downward forces are taken as positive from right hand side, as this have been told to you in case while making shear force and bending moment diagram cases. Okay, so as we are talking going from right hand side here, so downward forces are taken as positive. Okay, so when we are taking downward forces positive, so there is only one force that is coming, that is there, therefore shear force at C will be 1 and it will be positive. Now and this is the shear force at C. Okay, now this unit load has crossed this point, as and this point has come now here. Okay, this point has come here now, unit load is here now. Now when this point has unit load has crossed this point, C point, and now it is in span AC, so what will be the shear force equation at C? Then in that case you can write down shear force at C will be 0, while you have put your hand at x-axis and this unit load has crossed this point. So there will be no unit load here, therefore the shear force at C will be 0. Okay, now I have got the two equations. Now we have the condition that when x is x value, that is the distance of unit load, when x is less than a, this is first condition. When x is less than a, that means it is in span CB. Now the second condition, shear force at C, is for when x value is greater than A and less than equal to L. For that shear force is at C. Now for drawing the shear force diagram, simply draw the span. Now for condition when x equal to 0, when x equal to 0, I am saying that means shear force will be 1, because first equation is valid for that, as x is less than A. So shear force is 1. Okay, now when x equal to A, for that point when x equal to A, at that point also the shear force is also 1, and the shear force diagram will be like this. And second condition is x is greater than A and less than equal to L, for that shear force is 0. When x is greater than A, for that shear force is 0. So here there will be shear force will be 0, and for this shear force will be 1 here. Okay, so this is the ILD for cantilever. Now we have made the influence line diagram for the reaction and shear force. Now comes the third point, that is making influence line diagram for the bending moment. Influence line diagram for bending moment. So in that case, how will you make the influence line diagram for bending moment? For that, as I have taken a section here at C point, write down the bending moment equation. Bending moment equation at C. For that bending moment equation at C will be, put your hand uh, here at X point. You can put your hand here at X point and see the when the unit load is in CB. The moment at C will be, the moment is clockwise, and clockwise moment in case of cantilever beam is taken as negative, as and I have taken the anti-clockwise moment here, and anti-clockwise moment is coming out to be positive here, and therefore the clockwise moments are taken as negative. Moment equation will be -1 into the distance will be A minus X. Okay, so this is the bending moment, as the remaining distance from here to here is this distance I am talking about. This distance will be A minus X. So this is the moment that will be at point C. So bending moment at C is minus 1 into A minus X. So this equation is valid for when X is less than A. Okay, this is the equation of bending moment at C. For that case, you can calculate the bending moment as x equal to 0. When x equal to 0, the bending moment will be, you can put down in this equation and comes out to be bending moment will be A minus A. That is when x equal to 0, that means the bending moment at B we are talking about. And when x equal to A, when x equal to A, that means bending moment at C we are talking about. So for that case, A minus A will be 0. So bending moment at C will be 0. Now we have the second case. We have the second case when this unit load will cross this point. When this unit load will cross the point C, now there will be no unit load. In that case, when unit load will cross point C, in that case bending moment equation at C will be 0. There will be no bending moment, and the boundary condition will be that x is greater than A and less than equal to L. For that, you can put down the value at x equal to A. That point bending moment at C will be 0 and bending moment at A will be also 0 while putting x value as A. For that, you have got the ILD for bending moment. Now if I want to make this is the bending moment at C. So influence line diagram for moment MA. When we are talking about moment MA, so here is one moment, that is MA. For that, if I want to make a influence line diagram, so how will I make the influence line diagram for MA? Now for making ILD for MA, you have to see that this is the cantilever beam and this is point A, this is point B, and this is point C we have talked about. Okay, so when the unit load is here, now here unit load is here now, so this distance is x and this distance will be, that is L minus x. Okay, now in case of cantilever beam, clockwise moment is taken as negative. For that, the if I want to see the bending moment equation at A, that means I want to see the equation here, so we can write down the bending moment at A is equals to, bending moment at A is equals to 1 into that distance is L minus x, and this moment is clockwise, that means it is negative. Okay, so I have put the equation here, and this equation is valid when x is less than equal to L. Okay, in that case put the value when x equal to 0. So bending moment at B point will be, put the value 0 here, that will be minus L. This is first. And when bending moment equation when it is at A, put the value of x equal to L, that will be L minus L will be 0. So bending moment at A will be 0. So bending moment influence line diagram for bending moment A at point A will be, when it is for x equal to 0, it will be minus L. This is minus L. Okay, and A point is 0. So ILD for MA is this. And if I want to make ILD for bending moment at C, for that you have to make a span here. First see when x equal to 0. When x equal to 0, the bending moment at B is minus A. For that you can write down minus A. And at this is C point, so bending moment at C is 0. and other bending moment at C and A is 0 0. So this is 0 and this is 0. So this is the bending moment ILD when it is we are talking bending moment at C. This is how you need to draw the influence line diagram in case of cantilever beam. So these are the method that we adopted for making the influence line diagram. Now in other lecture I will be telling you about how to directly make the influence line diagram for all the cases, how we can make influence line diagram in a simpler manner. So you can make the influence line diagram for the continuous beam. So this is your assignment, that if this is a hinge support here and a roller support here, this is V point, this C point, okay, this is distance L, this is distance Z. So you need to make the influence line diagram for the reaction, for the shear force and for the bending moment for this case. Okay, thank you very much.